Hi. Glad you all came back. Whoa, it's busy out there. Okay, so we are going to talk about identity stuff, OAuth, OpenID Connect. Nicolas Garnier is in Google Zurich, and I'm in Vancouver, Canada. So this is a transcontinental presentation, and I want you all to remember that identity is very serious business, so there will be no jokes. Nicolas, okay? No jokes.
I'll try.
In this session? Okay. So let's talk about this stuff. So as with the previous session that I was talking, I think it's important to start when we're going to present some technologies to you, and you should know what our interest is, in the interest of transparency. So basically, as I talked about this morning, Google wants you to be online as much as possible. And one of the important things in achieving that goal is to remove the pain points. If there's anything painful about being online, well, we're against it. We want it to go away. And I think it's easy to believe that one of the most painful things about being online is logging in, typing passwords, remembering passwords, managing passwords, that kind of stuff. So let's get rid of it. The second point is a little bit more subtle. Google, of course, really wants you to use Google Search all the time. And we discover that a lot of times when people are looking for something, instead of going to Google Search, they go to Craigslist, they go to Emily's List, they go to Amazon, they go to other places. And if we ask them, well, why didn't you just go and search for it on the web? They say, oh, well, if I found it, then I'd have to go and log into that site and remember my password, and that's irritating. So by reducing the difficulty of logging in, we think we can increase the use of Google Search. And very important, we want to personalize the experience of searching. We think the best thing we can do to improve the results of search is by making it personalized. Of course, Google Plus is working very hard on that stuff. And that doesn't work unless we know who you are. So once again, identity leads to personalization, leads to better search quality. So there's a lot of technologies out there. The important message we're bringing here today is that Google is betting on two of those technologies, OpenAuth and OpenID Connect. Now, there's been some controversy around OAuth2 recently, and some of it is deserved. OAuth2 is a little bit bigger and a little bit more complicated than it needs to be. Fortunately, there are large parts of it that you can ignore that are really not essential. Inside OAuth 2.0, there's a fairly, moderate-sized kernel of stuff that you can really use. OAuth 2 is not an internet protocol, the kind of thing where you can plug two boxes in and they work. OAuth 2 is a general framework with a bunch of different flows in it for getting and using tokens. And what that means is that if you are using OAuth 2 to access Google APIs, you can't necessarily use the same code to access Facebook APIs or Twitter APIs. That's a pity, but it's okay. OAuth 2 is still very useful and ready and cooked, and the libraries are pretty good, as Nicolas will show you. OpenID Connect is actually really a protocol. They are trying to fill in all the gaps, dot all the I's, cross all the T's. So if this box does OpenID Connect and that box does OpenID Connect, the two boxes should be able to talk to each other and interoperate, and it should all just work. So that's what Google wants. That's what the technology backdrop is. That's what we're betting on. Anything Google is doing by way of offering APIs or identity provision will be based on OAuth 2 and OpenID Connect. That's where all our investment is going. So with that, I'm going to turn it over to Nicolas, who will tell you about what those things are and how they work in practice.
Thank you, Tim.
I'll be back.
By the way, this is really Tim Bray, just doesn't have the hat on. Proof it's Tim Bray is here. Okay, so hi everybody. So before we dive into, and no more jokes, of course. Before we dive into OAuth 2 and OpenID Connect, it's important to define some terminology first. There's lots of terms associated, to like OpenID Connect and OAuth 2. The first two I'd like to explain to you up front. The first term is authentication. So it's really important to know what authentication means. So authentication is basically knowing who the user is. So when a user goes to your website and signs in, enters his username and password, you're going to know who he is. Basically, he's going to validate his identity, and you're going to know a few things about himself, probably his name, at least the name he entered, maybe a unique identifier. It's probably sometimes people use the email. Sometimes it's actually a unique ID, a number. So the second term that's really important to differentiate from the first term is authorization. So authorization is really giving the user access to the correct data, right? So when the user has entered your website, sent in your website, it's important to show him the right data, right? You want to show him the correct email or his correct contacts, not somebody else's contacts. So that's authorization, is really giving access to the correct data, basically, enabling access to the correct data. And it's really important to differentiate the two to understand what we're going to talk about during this talk, authorization and authentication. So many people, mix the two up because they basically use auth. When I started working on this, I mixed this like pretty bad. I was always, saying authentication when I meant authorization, because many times you just use the term auth. It's really important to differentiate the two. So now a few questions for you. So who in the room have ever in his life shared a password with a third-party app so you could use your data? For example, I don't know, you go to this website and it asks you for your password so it could access your contacts. Who have done that? Usually it's everybody. So who have not done that? No, you guys are just trolling me. All right, so you have a few opportunities here because, of course, doing this is bad, right? You don't want to do it, but many people do this. You want, to make the web safer, basically eliminate the need for users to reveal their passwords to another app. That's pretty basic. You want to make the web safer. You don't want people to enter the password they have on a system and give it to somebody else. That's bad. You want to make it safer, and it's not, it's a duty for you as a developer to do this. You don't want people to have to do that to basically use a cool feature on your website. It's really your duty. It's going to be good, for you and for your users. So, and that's what OAuth2 for authorization is all about. Okay, another question. Who have ever used the same username and password on 2 websites at least? That's everybody. Who have never done that? Come on. Okay, boo. You're just such liars. Who have never not done this nor the first question? Who have not done that? Real troll here. Okay. All right. Okay, maybe that's possible, but you must be German or something, right? No? Okay. All right. Okay, of course everybody does that, except maybe a few that I just discovered. And so how many keystrokes do you type when you sign up for a new account? Who wants to guess? Calling out some answers. 16. 16? Wow, only 16? Oh, okay. Well, 100, yeah, maybe. It's probably 50 plus, right? At least you type your username, your password twice, and probably your email, right? That's at least 50. So again, you have a few opportunities here is to make it easier for your users. You don't want, and also make the web safer again. You don't want your users to have to retype the same username and password. You know what happens, right? Every once in a while, we see, that some big website or, have been hacked, and they stole all the passwords. So what's going to happen? The hackers, they're going to try to use these passwords on multiple other websites that they have not hacked, right? Probably hacking Google is super hard, of course. Nobody have ever done that. No. What they're going to do is they, typical attack vector is, some hacker is going to go and hack that little e-commerce website that has, very poor security. He's going to steal all the, all the username and passwords there because it was easy, and then he's going to try all these username and passwords. If you happen to have registered a Gmail account, he's going to try to use the same password to log into your Google account. And whenever you learn on the news that some big website has been hacked, usually if you have used the same username and password, the first thing you have to do is go and change them all, right? Otherwise, some bad stuff is going to happen. So you don't want, that's the same thing. You don't want your users to have to reuse username and passwords. That's bad. And the same way, you want to optimize, the flow, the sign-up flow for your users. You don't want them to spend too much time signing in. It's like, oh shit, I have to sign up again for that website. I have to type so much things, So that's all. That's about, what OAuth 2.0 for login is about. I call it OAuth 2.0, for login. Another name is OAuth 2.0 for authentication, and that's also the name of basically the OpenID Connect protocol. Which is not finalized yet, which is why there's so many different names. So the same thing. So now we're going to see in detail what OAuth 2.0 for authorization is and how it's working, basically. And later on, Tim will show you how it's working for authentication, OpenID Connect, basically. So first, just so you know, Google has more than 35 APIs enabled with OAuth2, more than 35 OAuth2 protected APIs. It's more than that, but I even don't know, whenever Google launches stuff, it's like all the time. So we kind of keep, lose track. It's more than 35 and other. Of course, there's many, many other OAuth2 providers, just to name a few, for example, Facebook, Microsoft, Salesforce, for example. So it's really widely used now. Now that the spec is final, more and more people will start using it. So it's really becoming a standard across the web. You really want to know how that works. So when you use OAuth2, here you're authorizing. What's your goal? So the goal is to get an access token, basically. The access token is really what you need. It's what's going to give you access to the API, to the user's data, basically. Usually how that works is you have the resource owner, right, which is the user. The user owns, it's his data, right? And he's going to tell an OAuth2 provider or the people providing the API, like, for example, Google, hey, I agree that this application use my data and only that part of my data. So that's kind of how it works. It's like multiple people involved, right? The user, the OAuth provider, and the client. The client is your application, right? That wants access to that data. And at the end, you get an access token. So that's really the goal. All of the OAuth2 flows, you'll see there's many, many different ways to use OAuth2. The goal is really always to get that access token. They all end up at that point. You get that access token, that's your goal. Once you have it, you can access the APIs. So how do you use it? I'm kind of starting by showing you the end, how it works at the end. Because it's simpler, there's only one end, right? You have the access token, you can use it. Then you'll see there's many, many different ways to use OAuth2 and get that access token, and we'll describe a few. So there's actually two ways to use it. The first one is to use that token. Here is some access token in an HTTP header. So you pass it in the authorization header with a prefix, which is bearer. And there's a second way to use that is to pass it in URL parameter here using access token, the access token URL parameter. It's usually a bit safer to use the first one because this one might get logged. It's more likely to get logged by some intermediary server, probably yours. Usually you want to avoid that getting logged. Some people could hack your log if it's less protected than the rest of your system. It's usually a bit safer to use that. And that's it, right? You send a request, a post request, a GET request, whatever type of HTTP request needed to access the API using that access token, and that's it. You got access to the OAuth2 protected resources that's available on the API. For example, at Google, it's mostly REST APIs. So it's going to be, get to read an object or a list of objects, post to add a new one, etc. So now how to get started? The first thing you need to do is register your app. So that's valid for if you're using Google APIs. That's also valid if you're using any other OAuth2 providers out there. You need usually to register your application somewhere. So at Google, if you want to use Google APIs, you go to the APIs console. That's how we call it. And that's the URL up there, developers.google.com/console. Same thing for Facebook. You go and you create an application. You kind of tell them who you are as a developer. At Google, you tell them what type of APIs you're going to use, and we grant you quota there. That's where we manage. If you want more quota or free quota, or if you want to pay for your quota, some APIs you have to pay for. That's all handled there. But basically, the most important is that you go there, you tell us who you are, and we're going to give you OAuth2 credentials. These OAuth2 credentials for developers, there are two things: a client ID. And a client secret. So these two things, they really identify your application, and you need them in the OAuth2 flows that I'm going to show you right after. So the first flow we're going to talk about is the pure JavaScript flow. So there's many names for OAuth2 flows because the protocol has been talked about during I think 3 years or so. I think you can confirm, 3 years or so. So it's a really long time, and the name of these flows changed. So there is the JavaScript flow. I think there was that's been called the user agent flow before. And now it's like the implicit grant flow, right, in the final spec of the doc. So that's not the actual correct name. right here, the JavaScript flow. That's the name I'm giving it, because that flow, you can basically only use it in JavaScript application, and we're going to see why and how it works. So here's the flow and how it works. I'm going to describe you, step by step how that flow works. So first step is you have your application. That's kind of the user experience and the developer experience here you see on these slides. The first step is you have an application here. The user is on your web page. For example, your app is a web app and called Taskman. What Taskman wants to do is list your Google tasks. Google has these tasks. In Gmail, you can create little tasks, and there's an API to access them. So very simple. Taskman wants to list your tasks and get access to it. So there's a button, right? The user has to click that button to authorize. It basically says, go to Google. It's kind of like authorize the tasks API. Give me access to the tasks API. So once the user clicks this, a pop-up window is going to open, or it could be redirected directly to a full web page, where he's going to ask, basically, that lives on the OAuth2 provider's website. Here you see you're on the Google domain. If if you're trying to access a Google API, you're going to be on the google.com domain. So the user knows he's on the correct place and grants you access or no. Basically, we ask him, hey, Taskman wants to access your Google tasks. Allow or deny access. Well, most of the time, the user clicks allow. At least that's what you want. And then he gets redirected back to your application, or the pop-up just gets killed. And we pass you in the URL parameter here. I mean, not as a URL parameter, as a hash fragment. An access token directly. So here, 1, 2, 3, 4, 5, 6. So you got your access token. That's it. That's your goal. You wanted that access token. We passed it directly to you in the hash fragment. Why is it safe? Is because the hash fragment is only exists on the browser. So it gets passed directly from that redirection here to your web page and given to you by the browser, and only JavaScript code can access it. No intermediary server can try to steal it, or man-in-the-middle attack is not possible in that case. So that's it. Your application has the access token and can use it directly to query the Google Tasks API server. That's it. You've read the Google Task, and you can display them on your website. Okay, now let's see that flow in action, actually. So there's a little button here. Let's see it in action. When I click, that's actually a pop-up. It just seems like the full screen because I've set the browser in full screen. So I got redirected to Google, and Google is asking me, hey, Taskman wants to manage your tasks. Basically, read and/or have the capability to read and/or write your tasks. So you're probably going to allow it access. And here I get redirected back to my app. So here the slide deck is my app. It's HTML5 slide deck. So I just embedded some JavaScript code in there. And got the access token and was able, to basically read your tasks and display it. You probably want to know how you do that, actually using actual code. So that code here shows you how you can do that using the Google APIs client library. So of course that only works if you're going to access Google APIs, not if you're going to access, of course, other OAuth2 providers' API. So what you do is very simple. You have to set up your client ID here. Of course, your scopes. Scopes are very important. They define what type of data you want to access, you want to get access to. So if you just want access to Google Tasks, you list the tasks here at Google. It's kind of a URI. In the specification, in the framework, it's just a string, right? Other OAuth2 providers have just strings, like user info or something like that. At Google, it's usually kind of in the form of a URI like that. And you can get the token just by doing gapi.auth.getToken. If the user has not approved yet, the user gets that pop-up, and grants you access or not, and then we give you the token right away. You probably want to know how you can do that with pure JavaScript, of course. Not all of you are going to use Google APIs with OAuth, or basically. So if you're not using Google APIs, if you're using Google APIs, you should really use our client library. It makes things a lot easier for you. The protocol kind of works like that. You have to construct an API, a URL, to which you're going to redirect your users, basically. So that's quite simple. So first, there is an authorization endpoint. So usually, OAuth2 providers have two endpoints. The authorization endpoint and the token endpoint. Token endpoint is to use in another flow that I'm going to show after. This is the authorization endpoint. Is kind of the base of the URL to which you're going to redirect your users to, where that grant screen is. So you have that. And then you need, of course, the redirect URI. The redirect URI is your application, basically, where we're going to send back the user when he has granted access, basically. We're going to send it back to that URL and pass you the access token, or an error if it isn't approved. You also need the scope, of course, and the client ID. We talked about it just before. And basically, here I just concatenated, that string, the specific URL parameters that you need to use, redirect URI for the redirect URI, client ID, scope. And here I just opened that, in a pop-up. You could also simply redirect the user to it. That's how it works. Very simple, the first step. And here is a URL concatenated already, kind of how it looks like for using Google's OAuth2 and asking permission to access tasks for that particular client ID. That's the first step. You redirect your users there. Oh, sorry, another URL parameter that's very important here is response type equal token. That basically defines which flow you're going to use. Here I'm describing you the JavaScript flow. That's kind of the code, the URL parameter you need to use to say, hey, I want to use the JavaScript flow. I want to directly get an access token. And then the user gets shown this grant page, basically, this grant screen. And he's redirected back to your application. That's the URI, the redirect URI, and the access token is passed in the hash fragment here. And you can read it using JavaScript. And that's it. You've reached your goal, basically. You have your access token. You can use it to query APIs. That's the goal, getting the access token in each of these flows. There's a few other parameters that are passed in the hash fragment. One is just the token type. You don't really need that. The second one is really important. It expires in. So typically, each access token expires, not valid for an indefinite time, right? Typically, at Google, they are valid for 1 hour. That expiry time is in seconds. So be aware that the access token you're getting is only valid for a certain time. It's up to the OAuth2 provider to set how long it's valid for. Some may have it valid forever. I don't think that's very, very safe, but it could be possible. Here at Google, they're always valid 1 hour, basically. So questions. There's a few questions you might ask yourselves, and we're going to try to answer them in advance quickly, so you don't have to ask them at the end. They're probably going to come up. So the first question is, how do I get the token back to the app from the pop-up window, right? Because when it's a redirect, it's easy. You get redirected back to your app. It's in the hash fragment, you read it. If it's in the pop-up and you want to kill the pop-up, how does it work? Well, usually you would set up a redirect URI to go back to a web page you have. That's going to use, post message or probably, frame-to-frame communication and basically pass it back to your mainframe. That's kind of like the way to do it. Second question is, how do I get another access token? So to get another access token, well, you have to make the user go through that flow again. That's the only way using the JavaScript flow. You pop up again, the grant screen, or you do the redirection again. Except typically for second use after he's approved and granted you access, he's not going to be presented with that grant screen, right? Allow or not. You'll get auto-approved because he's already given you access, give you access to your application, basically, and we kept that in memory. So the grant screen is going to be bypassed. So if you do a pop-up, there's going to be a pop-up boom that's going to disappear right away. If you do a redirection, he's going to be redirected back and forth automatically, and you'll get a new access token right away. And what happens if the user isn't logged in to Google, for example, if he wants to access Google APIs? Well, in that grant screen, we're simply going to ask him to log in, right? That's the way it goes. The user logs in, and then he gets presented to with the grant screen, sorry. So another few questions is when to use this flow, right? You want to use this flow only if you're using JavaScript first. That flow basically almost only work in JavaScript because you need JavaScript to read that hash fragment. You're looking for simplicity because you're getting that access token right away, right? You'll see with the other flows that are a bit more complicated. With this one, you get directly the access token. That's the most simplest flow. The user grants access, you get the access token, you can access the API. It's very, very easy. And the third one is you only need access when the user is logged into Google. That's true, right? If you want access while the user is not logged into Google, you want, background, basically backend access, and be able to use the API while the user is not logged in and hasn't granted you that 1 hour access token that way, you'll need to use the other flow that we're going to see right after. So this other flow actually is called the server-side flow in Java. The official name is authorization code grant flow, I think. Yeah, from the spec again. You know, I call it server-side flow because, well, you're going to use it server-side, obviously. And how it works is this way. You'll see this one is a bit more complicated. There's basically 2 extra steps. How it works is this, you know, the user experience is the same. The user goes to your Taskman application and needs to, you know, click that button to grant you access. He gets redirected. This time, only redirection. You don't usually do pop-ups for this. Gets redirected to Google, to the Google grant screen. And on the Google grant screen, you know, he's probably going to click allow. Same user experience. Except there, the developer experience changes a bit, right? The user gets redirected back to your application, and this time, instead of passing the access token in a hash fragment, we're going to give you what we call an authorization code in a URL parameter. Difference between hash fragments and URL parameters is URL parameters, you can read it on your server side directly. They're part of the HTTP request. So what you're going to do on your server side, you're going to basically, you know, read that URL parameter, that code, and there's an extra task for you an extra step. Let's not mix the terms. An extra step, which is exchanging that code. You need to, there's a special request we're going to see right after. You send that code to Google OAuth servers, and Google server is going to reply back and give you an access token, basically. So that's it. You've reached our goal. You have your access token. There was an extra step involved, basically. You get that code, and you have to exchange the code for tokens. That's the extra step. So now let's see how it works. Is everybody in the room a Java developer? Okay, I hope, because they told me it's a Java conference. So that's why, you know, you'll see mostly Java simple. Sorry, the first step up there, that's using Google Java client library. If you're using Google APIs, Google OAuth2 protected APIs, use our client library. I'm going to explain why, but they make things super, super easy for you. First step using our client library is to instantiate, you know, these 3 dependencies. You always have to do that with our client lib. Then the second step is to construct this kind of like flow object where you pass it a client ID, a client secret. You know, you got that from when you registered your app from the API's console. The scopes, of course, the scopes is like, hey, I want to access tasks data or calendar or whatever, Google+, you choose. And then you have this one-liner here again where you just going to create that URL. You need to redirect the user to, given your redirect URI, where the user is going to be redirected back. And here, since you're most likely in a servlet environment, you just do the response.send redirect to that URL. The user gets redirected to the application. To the grant screen. So that's what the URL looks like. Again, it's very, very similar to the JavaScript one, except there's two differences here. Is the response type changed? It's not token, it's code. You want basically an authorization code back. That defines that you're going to use the server-side flow. And also, there's this extra parameter here that's going to be very convenient for you. Access type equal offline. If you use this, we're going to give you what we call a refresh token. And I'm going to explain what a refresh token is. It's basically going to give you a limited access to the API in time, right? You know, these access tokens, they're only valid 1 hour. Well, the refresh token is valid forever. You'll see how we can use that. So you want to add that if you want like backend access, you know, unlimited in-time access, not only for 1 hour, for like forever. So the user you redirect your users to that URL. And the user, after granting you access, gets redirected back to your application to probably what we usually call the OAuth2 callback. The OAuth2 callback, we pass it a code URL parameter here. And this code is the authorization code that I said you need to exchange for tokens. So usually in your servlet, you read that code. Then if you are using the Google Java client library, here is how you exchange your code. It's very easy. You read the code from the parameter, the value of the code URL param. Then with this like one line here, that's basically going to exchange the code and give you access tokens and refresh tokens. And that's it. We've reached our goal. You have an access token after exchanging that auth code. So a quick word about our client library. I'm going to show right after how you do that using the raw protocol, HTTP requests. If you guys are really Java developers and want to use OAuth2 providers that are not Google's, you could still kind of go and check out our Java client library because, well, first it's Apache 2 license, so it's kind of open source. You can use it. You can probably use part of the code, and it's really modulable, right? There's many reusable parts that you could use to use it to basically be able to use that API and make it compatible with another OAuth2 providers that's not Google. You should check it out. The Java client library is very well made, and there's many layers which you could reuse. Okay. Now, since you guys are not always, gonna use Google OAuth, here is how you're gonna use the. You can basically exchange that code for tokens. As you need to send that HTTP request here. It's a POST request to the token endpoint this time. Here's Google's OAuth2 token endpoint, we call it. You pass it the client ID, the redirect URI again. You pass it the grant type. It's an authorization code that you're sending. You're giving that code, actually, and you're passing us the client secret. So the client secret, which usually keeps secret, and which basically is where you use it is to exchange the code for tokens. And Google, in case, or the OAuth2 provider is going to return you this nice JSON response, JSON object, which will contain usually an access token, again with the expiry time, and potentially a refresh token if you've asked for it, or if the OAuth2 provider supports that. Google supports that. So how do you use the refresh token, basically? That's going to be our next topic. As I said, you use the refresh token to basically refresh the access token. Access tokens, they're only valid 1 hour. So what you're going to do is you're going to send a special request to the OAuth2 provider to get a new access token. That refresh token is kind of the key to that. So here's how you do that using our Google client library, is you do nothing. That's why you should use our client libraries if you're, using Google APIs, is because we handle things like refreshing the token automatically for you, completely transparently. So there is 2 techniques to do that. I think the ones that's used in the Java client library is whenever you're trying to do a request to the API, if the response is a 4 or 3, unauthorized error, we're going to try to refresh the token automatically and then retry the same request again. So, and we do that completely transparently. You don't know about it. So we try the request the first time. If we get, oh, this is not authorized, this is not working, we refresh, get a new access token, because that's probably because the access token is not valid anymore, has expired. And then we try the request again automatically, and usually it works. So if you do that using the protocol, or if you're not using our client libraries, this is how you do it. So you send this HTTP request. It's a POST again to the token endpoint again. And you're going to pass it again, the client ID, the client secret, the refresh token, and the grant type this time, is going to be a refresh token. That's going to give you back again in a JSON format the access token with its expiry time and everything. So that's it. You've reached your goal again. You've got a new access token. You can use the API 1 hour again. So the second technique to do the refresh, I told you about the 4 or 3 error, if you have an error, trying to refresh. Of course, the other technique is to take into account that time, kind of like use that access token for 3,500 seconds, let's say, and if you see that that token is close to expiry or has expired, automatically get a new one, when you need it, of course. So questions again, we're going to try to respond to a few questions in advance, is when do refresh tokens expire? So somebody knows? When? Never? Yeah. Okay, good answer. Refresh tokens never expires. The only thing that can happen is a user can revoke a refresh token. So in the Google world again, you can go to your user account. You see all the refresh token that you've granted, with the application name, and you can choose the one you revoke. So what that's going to do is that's going to render the refresh token unusable. So what happens there is your application needs to detect that, if that happens ever, and ask the user to grant him access again. You basically redo all the OAuth flow. how do I store the refresh tokens? So the refresh tokens, you need to keep them, right? That's what's going to give you unlimited access to the API. You need to keep them in your database. It doesn't have to be super protected. They're only usable with your client secret. So your client secret needs to be very, very protected, right? So don't lose it. Otherwise, people can go and steal your refresh tokens, get new access tokens on your behalf. You don't want that to happen. So refresh tokens is, store them normally. Your client secret, really keep it secret. And when do I use this flow? So there's lots of when. Basically, the first thing is when you're looking for long-lived access to the user's data. That's, contrarily, as opposed to the JavaScript flow, here you can get, long-time access using the refresh token. You can get unlimited access in time. You need access when the user isn't at the keyboard. Same thing. Be able to use that refresh token to programmatically get new access tokens without user intervention. You need to call the API from server-side code. Well, as opposed to the JavaScript, which we pass the access token in the hash fragment here. We pass them in euro parameter, which we can read from server-side. And it's more secure. It's a bit more secure than the JavaScript flow here because the only person that can get that refresh token, that can get the access token, has the the client secret, right? Which is, we know it's completely secret. There's a few ways, of course, to hack if your site is kind of vulnerable, to hack your site and try to steal its identity. Probably IP hijacking or that kind of stuff could work. Or if people, inject JavaScript into your site, they could steal these access tokens, which could happen in the JavaScript flow. Tell me more about scopes. So I told you scopes is basically a list of strings of the data you need to access here, the task API. You can actually, in OAuth, set multiple scopes next to each other. It's just a space delimited list. For example, here you could get access to the request access to tasks API and also the Google Plus API in the same request. In the grant screen, we're just going to pile them up. Say, hey, task1 wants access to the task API and the Google Plus API. Okay, a last flow we're going to see very, very quickly before I hand over to Tim is the app-based authorization. I think that's called the client credential grant flow in the spec again. Oops, what happened here? Oh, auto update. Here you go. Okay. App-based authorization. Here, the use case is your application. OAuth2 has this flow where your application can basically authorize, basically access itself's data, basically the data that belong to the application. It wants to basically sign in as himself, right? So some APIs work like that at Google, for example. Am I going to remember the name of that API? Well, for example, Google Translate, right? Google Translate is an API you pay for. You need to authorize as your application to basically access it. There is no user that logs in Google Translate. It doesn't contain user data. It's the application that's using Google Translate. Same thing. I think it's Google Cloud Storage. Google Cloud Storage is for application, basically. You're going to use that as a backend for your app to put data in. It doesn't contain any user data, basically. How the flow is going to work, you'll see there is no user interaction. First, your app server is going to send sign requests to Google Auth server, so we'll see a little bit how you can do that. And Google Auth server is directly going to give him back an access token. It's very simple. So and how that works, that's again using our Java client library. So in the Google world, how you do that, that's also called service accounts, is you go to the APIs console, you create a service account. That's basically an account, you get that kind of email that represent your application itself. We also give you a private key. The private key is what you need to send that encrypted request to Google's OAuth servers. And we give it to you, that's again in the Google world. And I'm not going to go into the details of that protocol. You can check the documentation online. It's pretty complicated. There is encryption involved. But basically, just wanted to show you how that works because that's kind of simple using Google APIs client library. You basically use that, create that credential object setting again, these dependencies, the service accounts email, the scopes you need access to, and that private key file. Then the API is going to build that encrypted request and automatically give you an access token. You've reached your goal. You can access directly the API. Tools. Tools, very, very quickly. If you want to know how, you want to use a nice tool to try to understand how OAuth works, you should use the OAuth2 Playground. It's a tool I've built, actually, that really shows you step by step and shows you the protocol, basically on an HTTP request level, how the OAuth2 protocol works, basically. You'll see the redirect, you'll see the refresh, everything I've showed you on in the slides, you'll be able to see using that tool. It's very, very convenient, really drives you through the steps of OAuth2. And then you can use Google APIs. Any OAuth2 protected APIs, actually, because you can configure the tool logo here if you use it. You can configure it with third-party OAuth2 providers. It doesn't only work with Google APIs. I think I've tested it with Microsoft's OAuth and also Salesforce OAuth and probably Dailymotion. That all works. All right, now I'm going to hand over to Tim. It's going to tell you a bit about mobile and then authentication. Thank you.
Okay, so if you want to do authorization on a mobile device and get that kind of effect, there's a problem. If you look at the OAuth2 specs, they're very, very browser-centric. They're all talking about redirecting back and forth through a browser. And if you're in a compiled Android app or a compiled iOS app, how do you do that? Well, there's kind of three approaches. One thing is you can actually do the OAuth flows inside a web view embedded inside your app. Lots of people do that. It works. It's got one problem, which is that the embedded web view doesn't share the cookies with the main browser. So if you're already logged in, you won't notice, and you might end up forcing the user to do extra work. Next approach is you actually branch out to the system web browser, do the OAuth flow, and come back to your app. That works fine. Lots of people do it. It's got a couple of problems. A lot of app designers don't like the user experience of leaving the app, going out into the browser, and coming back. There are also potentially some security problems with that because apps on both Apple and Android can register to catch particular URLs. They might be able to jump in front of you and get your access token. There are techniques to work around that. You can go and read the documentation, but it's something to worry about. In the particular case when you're on Android and are working with Google accounts, there's this new thing as part of Google Play Services called Google Auth that allows you to do an OAuth2 flow and get an arbitrary token without ever going to the browser and with a pure Android user experience. It works really well. So if you use it, that's all the user ever sees. They never branch out to a browser. They just see Google Auth asking if it's OK to use this account for that API. Of course, if you're going to do that, you have to register your client. You have to register your Android app, just like Nicolas was saying. There's one thing that's different is you actually have to provide the signature of the cert that your app is signed with. That makes everything a lot more secure. And then you go on and you call Google Auth and it's a single call to get the token. It hides a lot of those steps behind it. Now, it turns out that the process of registering your app, getting the signature for the cert, and making the call is a little bit more complicated than you like because it's asynchronous. It's going to be doing a lot of network talk, so you can't do it on the UI thread. And it also, in the middle of the call, might want to go away and talk to the user and ask, oh, is it OK to do that? So you have to be able to prepare to go off to another activity and come back. Anyhow, as I was saying, it's kind of complicated. So we wrote a great big long blog entry back in September explaining step by step by step by step what you have to do to make this work. When it does work, it's great. It's really by far the best way to access Google APIs on Android. And we're really hoping that the rest of the industry will sort of climb on board the OAuth bandwagon and get a better user experience. Okay, that's all about authorization. Let's talk about authentication, getting people logged in. So that's what OpenID Connect is about. So this is what we're typically seeing, you're used to seeing when you go to some website and you want to join in. And people see this, and the research shows perfectly clearly that a substantial proportion of the people who see this will just turn around and walk away because they don't want to go through the pain of filling out your stupid fields and guessing a password and all that kind of stuff. So we think an email form should look like that, where for Google you could have Facebook or Twitter or Microsoft Live or whatever. Just click the button and get in. Maybe if you've got multiple emails at Google, you might want to specify which email you're going to use, but that's all a sign-up form should be. And there's really a lot of upsides for doing that. It's very, very beneficial to make it easier for people to get into your website. It's very, very unpleasant for people to have to type passwords in, particularly on mobile devices. And also, once you know who people are, you can personalize your site. So here's how it's done. Instead of those scopes that look like long URLs, if you're using OpenID Connect, there are these pre-cooked scopes. If you ask for profile, that gets you a big package of information, their gender, their whatever they've agreed, a picture, that kind of stuff. Or you can just ask for just their email address. And the difference between those two is the prompt that the user is going to get. They're going to get a much more, scary-looking prompt if you ask for all that information, but people will usually just say yes. And then for this particular thing, here's an example of how you might put a request prompt together. Once again, as Nicolas says, if you're using Google libraries, that all gets taken care of for you. But if you're just doing raw REST in a client, it's still pretty easy to do this, to build the URL and send it off. Okay, so you send that off, or once again, if you're using our library, that's all there is to it. You just put a button in your HTML, and you call one JavaScript function, and it's all done. And then what that does is it comes back with an access token, and then you can go and call the token info endpoint, and it'll tell you some interesting stuff, like who issued it, Google, and what the scopes were, and so on. And it'll give you the email that it asked for, and here's what's really important. It'll give you this unique user ID datum. Now, if you're talking to Google or to any other OpenID provider, that datum, that is very important. It's just a string, but it's unique. And this stays the same across changes in email address and things like that. You can also go back, if you've asked for the user info, and get a bunch of very useful information, such as a link to a picture and all that kind of stuff. OpenID Connect is widely implemented, even though it's not quite finished yet. There's still a few pieces of the spec that are working. It provides a really superior login experience. I just finished implementing OpenID Connect against the Google endpoint, the Microsoft endpoint, and the Facebook endpoint, and they're all slightly irritatingly different at the moment, but it's still pretty easy to do. There's also a tool, like the tool Nicolas showed you. He wrote this one too, that will step you through this. Okay, in my last few minutes, let's talk about this. I mentioned this in the keynote this morning. You've got a client app, you want to talk to your backend, you don't want to have to log in. How do you make that work? So there's a few steps to it. So you register your project, just as Nicolas was showing. Inside the project, you make two client IDs, one for your Android app and one for your backend. They get different client IDs. Those are both strings. Okay? And then on your Android app, you go and you get an OAuth2 token with a very, very particular scope, like that, saying, and what happens is, when you ask for that client ID, for that token, Android looks and notices that both of the client IDs are in the same project. So we know the same user controls both of them, so we don't ask the user for approval again. We say, okay, yeah, we'll just give you that token. So you get the token, you send the token off to the server from the client, using HTTPS, of course, because it's secret data. And then the server validates the token using a Google library. This is very, very easy, and it's also static, because it just checks it against a public key that you get from Google that we flip every day. Oops, I flipped it backwards there. And then you validate that, and you check the audience fields inside the token. After you've done these things, you can be pretty sure that we generated the token, and that we believe that person was logged in, and we believe they were using that client. So what you've got automatic validation from an Android app to a mobile backend, good security, good user experience, no fuss. Sounds wonderful. What's the limitation? The limitation is it only works on Google accounts, and it only works on compatible Android devices. So if you're using a Facebook account or if you're using a Kindle, you can't do this. But if you're on a compatible Android device, of which there are hundreds of millions out there, this is a really slick way to go. Okay, the last thing I want to talk about is that thing I demoed during the keynote this morning, Account Chooser. So a bunch of mobile sites are going to start using this. So when you go to the site for the landing page, and if you're not already logged in, you don't see a complicated page, you just see this. You see a little bit of branding from the site there, and you see a list of accounts you've already used. Why would anybody use this thing? Well, because it gives you one-click login and one-click sign-up. People who are trying to ease sign-up would use this, but enterprise people would use it also. There's a lot of subtle advantages to using this. If, for example, the way it works is when they click on it, it feeds back to your application in a way I'll describe in a minute. So your application gets to intercept the click event and decide what they're going to do. Are they going to send you to an IDP? Are they going to log you in directly? This gives you one level of indirection automation in the login process, which you can use to help you like roll in an IDP if you're not using one or something like that. Okay, how does it actually work? The other thing I should say is, despite the fact that it goes to accountchooser.com, all the data is stored locally in HTML5, and it's specific to the browser. Okay, it's not specific. It's specific to the browser, so it's very, very secure, and nothing can be put in here unless the user agrees. So there's no secrecy, there's no sharing of data across the internet. It's all implemented in JavaScript in open source Apache 2 licensed code. So it's not Google proprietary. This is all copyright OpenID Connect, OpenID Foundation. Okay, so here's how it works. All you do is in your site, you put in a call out to accountchooser.com to go get this chunk of JavaScript. Okay, so step one. When they come to your landing page, you put that chunk in. It'll redirect over to accountchooser.com. If there are certain identity providers that you support, you can tell accountchooser.com, and they will only allow them to pick accounts that are associated with your identity providers. Okay, that's easy. So when they click on it, it's going to post back to an endpoint you have to provide. So you do have to provide one extra endpoint to make this work, and it'll post back, say, giving at least an email address, and maybe also an IDP if it's from your list. And if it has a photo and a display name, it'll post that back too. Okay? And that goes into your code. You can do whatever you want, but what the best things to do are to just return a little chunk of JSON, which either says, yeah, I know this person, send them to my login page. It'll send them to your login page, pre-fill the email address, put the cursor in the password field. Or you can say, no, I don't know this person. It will send them to your sign-up page, pre-fill the email address, put the cursor in the next field. Or the good thing to do is if you use an identity provider, you say, okay, here's the URL to start the identity provider login process, and it'll redirect off to the identity provider. With any luck, if they're already signed in at the identity provider, it'll just turn around and come right back to you, and you'll be all logged in. Last step is, when you get them logged in, however you do it, through the identity provider or yourself, you post back to AccountChooser saying, I logged somebody in using this information. Now, in most cases, since they first of all came from AccountChooser, the information's already there, so it's just a no-op. You go straight off to your app's homepage, you're all logged in, everything's great. If they're If you actually created a new email address that nobody had never logged in before, it goes to AccountChooser. AccountChooser will pop up a window saying, is it okay to store this email address to use for this site or for other sites to log in future? If they say yes, it goes into AccountChooser. So AccountChooser is self-seeding organically. When somebody starts using it, they'll never see it until the first time they log in with a site, and somebody pops up saying, oh, can I store that? And then subsequently, as they go into more and more sites, the relatively small number of email addresses they use to log in will have built up in AccountChooser, and there you go. And I love these slides. There is no step 5. That's all there is to it. So there you go. It's a 4-step thing. It's all done in JavaScript. It's easy. It's simple. It's straightforward. It's open source. It's non-proprietary. It's secure. I think this is actually going to become quite popular. So that's about all. OAuth2 and OpenID Connect have been cooking for a long time. They're here. They're working. They're widely deployed. We provide libraries to make it easy to use them. If you don't want to use the library, it's just a set of simple REST calls. It's still easy to use them. You should start using them. Every time you adopt this and chase one instance of having to type a password away from the internet, you're improving the internet. That's good for us. That's good for you. And that's good for all the people who use the internet. There's a bunch of resources, including these slides, which are just HTML5. I think we're pretty well out of time. Got time for one question. It says there 2 minutes. But Nicolas and I are going to go down to the Google booth after this, right? And so if you want to talk about this, chase us down there and talk about it. One question? Yeah, you.
How about privacy? Does this give OAuth providers and API providers the opportunity to know which user uses which application and we
No, no. So you're talking about account chooser, right?
yeah, or Google or Facebook.
Okay, so anytime you log in, you use an identity provider to log in, the identity provider could record that fact. You know, this user logged into that relying party at this time. So what you should do is go and look at the privacy policy published by your identity provider so that you know exactly what they're doing. And it is certainly possible to set it up so that it's not logged at all, for an identity provider to do that, if they want to offer that as a service. And one more question. Everybody's leaving. Yeah, you.
What if I want to be an OpenID provider?
Yeah?
Any libraries available? For instance, like
Oh, so he wants to be an OpenID Connect provider or an OAuth provider. Are there libraries available? There's not like a library that you can just plug in and it will work. But there are a lot of libraries around for Java, for PHP, for Ruby, for Python, with various bits and pieces you can pull together. Now, if you're a provider, you are going to have to do some cryptography, right? So it's not going to be that easy, but you're not going to have to build it all from scratch.
any that implement the last specification?
The account chooser?
No, not like OpenID 2.
OpenAuth 2? Yeah, yeah. It didn't change much in the last few releases, so they're mostly pretty well up to date. Okay, that's all. Thank you. Thank you, Nicolas.
오빤 강남스타일